right, here we are, 3.9, graphing quadratic inequalities. Everything is exactly the same as the review that we just did, except for now you see a big inequality symbol there. Okay? So you're going to treat it like an equal sign to begin with. You notice that it's in standard form. What's your first step? Find the vertex. And how are we going to find the vertex? Very good. Negative b over 2a gives us the x value of our vertex, right? In this case, that would be negative 2 over 2 times negative 1, or negative 2 over negative 2, or positive 1. So our vertex, we've got half of our vertex already, is positive 1 by doing negative b over 2a. Okay? Now, how do we find the y value? Plug it in. So I take 1, and I plug it in right there. I take 1, and I plug it in right there. So this is negative 1 squared plus 2 times 1 plus 2. That's going to be negative 1 plus 4, or 3. So my vertex is at 1, 3. All I did was plug that in. You could do it on your calculator. You could type it in, I guess, on those new fancy calculators, but you need to be able to get the vertex. Okay? Yes?
It says 2x plus 1, so you're supposed to put the 1 with that too?
The 1 goes there and there.
So how did you get...
Oh yeah, you change plus 1 to plus 2.
Plus 1
At the end.
Here?
No. It's the second step that you went to.
Negative 1 squared.
At the end, it's supposed to be plus 1.
Oh, sorry. Thank you. Thank you. Very good. So that makes it what? Plus 3, so the answer would be 2. Okay. Sorry. Yeah, I did. All right, questions. So now we have the vertex. So we do just like normal, and we say positive 1, positive 2. Here's our vertex. Is the parabola going to be going up, or is it going to be going down? It's going to be going down. But hold on before you graph it. At this point, I need to look at the inequality symbol. And if it is a greater than or equal to symbol, or a less than or equal to symbol, then my line is going to be a solid line. If it is simply a greater than or less than symbol, then what kind of line am I going to have? A dotted or a dashed line. Exactly right. I knew once we started doing it, it would come back to you a little bit. So here's my vertex. I know it's going down. What kind of line is it going to be? It's going to be solid. Here's my line here, and here's my line here. Now, we only have two choices, right? It's either we shade inside the cup, or here's the parabola and we shade outside the cup. Those are our only two choices. So we're either going to shade here and here, or we're going to shade here in the middle. How do we know what area to shade? Anybody have an idea?
It's greater than.
No. That works some, but I like a different method. Very good. We take a test point. And in this case, I want to use this point right here. Test point. I would say 90% of the time, what test point do we pick? 0, 0. But why don't I want to pick 0, 0 this time? Because of the way I just hand drew my graph, the graph might be going through 0, 0, and I'm not sure that it's inside or outside or on the line. So I want to pick a test point that I know without a doubt is inside the cup, or a test point that definitely is outside the cup. It needs to be definitively in one area or the other. So in this case, I'm going to pick 1, 0 as my test point and plug it in. Okay? I'm going to put 1 in for the x, and I'm going to put 0 in for y. So I get 0 is greater than or equal to negative 1 plus 2 times 1 plus 1. Or 0 is greater than 2. 0 is greater than or equal to 2. Is that a true statement or a false statement? That's false. An alligator is eating the smaller number. That doesn't work. This is a false statement. So here's my test point. It worked out to be false. So am I going to shade inside the cup, or am I going to shade outside the cup?
Outside.
Outside the cup. Why? Because if this is false here, then that means all these areas are now true. And that means I shade all these areas. And guys, when you shade, you don't have to shade every square inch. You just have to show me, obviously, that the outside is shaded. Okay? On the flip side, let's just say that this test point worked out to be true. Where would we have shaded? On the inside of the cup. Does everybody understand why we picked 1, 0 rather than 0, 0? Okay. 0, 0. All right, here's a question, drummer. What if they asked you and they said, this point right here, they gave you those coordinates or whatever, and they asked you and they said, is that point true? Is it work or is it not work? Is it not a solution? What would you say? What do you think?
No, because it ain't.
All right, I should have asked this. What about this point here? True or false? If they asked you that point, you plugged it in, it would be false. How about this point here? Would it be true or false?
True.
It'd be true. Now, what about one that's on a solid line? Because we have those bars, it's a solid line. Is a point on the line work or not work?
Not work.
It works. It's true. Write that down. You might want to put that point on the line. True. Over here, if there's a point on the line and it's dashed, then what's the answer? It's false. It's not a solution. Okay, that's what that means. Think about it like this. Is 0 greater than 0? No, right? That's a false statement. That would be over here, a dashed line. Is 0 greater than or equal to 0?
Yes.
Yeah, that's a true statement. That might be right here. Okay? Questions? Hit the thing and I'll do one more example. Well, it's time for lunch. Hit the camera, turn the camera on, and we'll do another example after lunch.